Welcome back to trigonometry. Today we're going to continue talking about identities. We've already talked about fundamental identities, but now we're going to get into the fun of this in verifying trig identities. What's going to happen here is that you're going to be given a statement that has an equal sign. Then from that, you have to prove that the two sides are equal. So you can't assume that they're equal. This is different than algebra equations. Not like algebra equations. Where you assume equality and solve. You don't know that the two sides are equal, so you have to prove that they are, and that's what it's meant by verifying the identity. And once you verify, once you've proven it, then you can use it from then on. Some helpful hints or some tips to keep in mind when in this process. First of all, make sure you practice, because the only way you're going to get good at verifying identities is by doing a bunch of them. Know those fundamental identities. Start with the more complicated side. Know how to work with fractions, factor, etc. Work with only one side at a time. And simplify as often as possible. I think these hints will make more sense once we start actually doing some verifying, but I want to go ahead and just get these down. When I say simplify as often as possible, that might mean putting things in terms of sine and cosine frequently. Sometimes when things are in terms of sine or cosine, it's easier to manipulate and work with everything. But those are some hints. Okay, so you're like, oh, okay, that's all fine and dandy, but what exactly am I doing here? What does this mean to verify a trig identity? Well, aside from giving you the hints, I think the next thing to do is to actually start showing you what's going on here. If we go to our first problem, we might be asked to verify that this equation is an identity. Okay, and we can start with something like this. Secant theta times sine theta plus cosine theta equals 1 plus tangent theta. Notice the equal sign. Now we don't know for sure that two sides are equal, so verifying, we're going to work with one side at a time until we can prove or get it to where both sides come out the same. Now I'm going to start with, this side, the one that looks more complicated. I will work with it until it looks like the other side, or I get stuck, or I have to stop. Okay, so keep it simple. I'm going to take secant and put it in terms of 1 over cosine theta. I find that a lot of times if you put things in terms of sines and cosines, it all plays out so much better. Okay, for now I'm only going to work with this left side. I'm going to leave the right side as is. And I'm going to hope that the left side looks just like the right side when I'm done. Alright, I'm going to distribute. So I'll have sine theta over cosine theta plus cosine theta over cosine theta equals 1 plus tangent theta. Well, sine theta over cosine theta is tan theta. That's something we learned with our fundamental identities. And cosine theta over cosine theta is going to be 1. And tan theta plus 1 is the same thing as 1 plus tan theta. So there we go. We verified it. By showing all these steps and working it out so that the left side matches the right side, we verified the identity. So showing the steps until left matched right, we verified the identity. Okay, that was a pretty straightforward one. Didn't take too much too many steps or too much work. Let's do one that's a little more involved. Let's see. Let's say we have cotangent squared x times tangent squared x plus 1. That equals cosecant squared x. Well, to me the left side looks more complicated than the right side, so I'm going to work with the left side. You can only work with one side at a time. I mean, you could end up working with left side and then later on switch over to right side as long as you're only doing one at a time. It's not like algebra equations where you subtract stuff from both sides or add or multiply or divide on both sides. It's not like that. You work with one side at a time. So I'm going to take this left side and I'm going to take cotangent squared and rewrite it as 1 over tangent squared. Then I'm going to distribute. Then simplify. And think back to my fundamental identities. I have an identity that says 1 plus cotangent squared is cosecant squared. And lo and behold, cosecant squared is what I needed. So now the identity is verified. Like, oh, okay, that one's not too bad. You know, I simplified it some and then distributed, simplified fractions, and then worked with my fundamental identities. Okay, next one. Tangent squared t over secant squared t equals 1 plus cosine t times 1 minus cosine t. Alright, to me the left side looks more complicated, so I'm going to work with that. I'm going to take tangent squared and rewrite it as sine squared over cosine squared. I'm going to take secant squared and rewrite that as 1 over cosine squared. Then simplify that down, I get sine squared. Sine squared, I have sine squared on this side, and I have 1 plus cosine t times 1 minus cosine t on that side. Well, one of my fundamental identities is that sine squared is the same thing as 1 minus cosine squared. I feel like that'll get me somewhere because I need things in terms of cosines. Which actually it gets me there very quickly, because 1 minus cosine squared can be factored into 1 plus cosine t times 1 minus cosine t. And there it is. Alright, this next one, no kidding, I tried this one like 3 times before I got it. Sometimes you start out trying something, it just doesn't work for you. And then you got to go back to the drawing board. So then working with fractions here, this one took me 3 tries before when I was working it out. Picking something to multiply top and bottom of a fraction on either side. So what I ended up picking was the right side. I ended up picking secant x plus tan x right here. I ended up picking that to multiply top and bottom on the right side. And that's what ended up working for me. Now it's not the only way to do it, but it's the way that ended up working for me. You want to try to pick something, when you have these complicated fractions like this, you want to try to pick something that's in one of the fractions if you can, because it'll all play out nicely. At first, I tried multiplying the left side by secant x minus tan x. And that ended up being a big mess I just couldn't figure out. Maybe it works, but I couldn't get anywhere, so I gave up. Then I tried on the right side multiplying top and bottom by sine x. That ended up being a mess, didn't work. So then I was like, you know what, the reason why this isn't working is because I can't seem to get this secant x plus tan x in the numerator. It just wasn't simplifying out like that for me. So then I decided, well, why don't I just take this fraction, multiply by secant x plus tan x in the top and bottom. That way, it's already there in the numerator. And that ended up being the ticket for me. Okay, so then from there, I had cosecant x I don't want to distribute this just yet. I'm not sure what's going to happen on the bottom when I multiply those together, because I'm going to end up with secant squared x minus tangent squared x in the denominator. And then I know that tangent or secant squared x is the same thing as tangent squared x plus 1. So you end up with cosecant x times secant x plus tan x. And this is actually working out rather nicely. Because cosecant is 1 over sine. So the secant x plus tan x is still left in the numerator, and then the sine x ends up in the denominator. Because remember, that was what was on the left side, secant x plus tan x over sine x. Okay, let's do one more. Just wanted to guide you and show you some examples. But the key is, once you finish watching this video, dive into your homework and practice, practice, practice. And if you get stuck on one, doesn't hurt to take a break and come back to it later. Try a different one. Sometimes you just need a fresh approach. Now this was one where I'm going to end up working with the two sides. And I'm going to try to get the two sides to match up. You know, sometimes you start working it out and you might feel like you're simplifying one side but not getting it to look like the other side. But you can always work with the other side independently until you get them both to come out to a third common statement. So I find the right one has the most promise in my mind, because I'm looking at, okay, up top here I can factor that into cosine alpha minus 1 times cosine alpha minus 1. Then on the bottom, negative sine squared alpha, that's the same thing as negative of 1 minus cosine squared alpha. So the bottom I've got cosine squared alpha minus 1, which that'll factor, because that's a difference of squares. You know, that factoring stuff that you do in intermediate algebra and college algebra comes back here a lot. That difference of squares will factor into cosine alpha plus 1, cosine alpha minus 1. And at this stage, this doesn't look anything like the other side. But you know what? I'm not going to panic. I'm just going to say I'm going to take the other side and work with it to see if I can get them to match. Okay, the other side, I've got cotangents and cosecants. I'm going to rewrite those in terms of cosines and sines. I just find that so much easier to work with. Okay, so then I've got cosine alpha minus 1 all over sine alpha in the numerator. I've got cosine alpha plus 1 all over sine alpha in the denominator. Well, these sine alphas are going to reduce, leaving me with cosine alpha minus 1 over cosine alpha plus 1. And that's exactly what I needed, because that's what I already got the right side to look like. So if I can get the left side and the right side to match up, even though these aren't the original statements up here, as long as I can work with each side independently and get them to match up, I have verified the identity. So that's another way that can be done. You may not just work with, you can either work with one side and get it to match the other, Or you can work with both sides independently and get them to match a third statement. Okay, so that's a little bit about the process here. Again, dive in, practice, and then in the near future we're going to be developing some very common identities that are used and that are going to be very important in the future if you go on to take calculus classes. Verifying identities in general is important if you're going on to calculus, because you're going to often have to rewrite things in a simpler form to work with them, or you're going to need to be able to use this process when you start finding certain derivatives and integrating, doing all kinds of calculus stuff. So you want to get really good at this verifying process. Okay, so that's it for the introduction for now. Please join us again soon for more specific identities. We're going to develop the identities and then look at how to use them. So lots of very common ones that we're going to be addressing. Thank you for joining us.